Lesson 1.8 is about perimeter, circumference, and area. The perimeter, or P, of a polygon is the sum of the lengths of its side, okay? The area of a polygon is the number of square units a polygon encloses. For figures such as squares, rectangles, triangles, and circles, you can use formulas for perimeter or circumference for circles and area, okay? So if we wanted to find the perimeter of a square, all right, all squares have the sides are the same lengths, okay? So you could either multiply that one side by 4 or just add all the s's together. And to find the area, it's the side square, okay? Now for a rectangle, we have a base and a height, okay? So the perimeter is 2 times the base plus 2 times the height, and the area is the base times the height, okay? Now, a triangle for the perimeter is just the 3 sides added together, okay? So A, B, and C, you add those 3 sides together, and you get the perimeter, okay? When you want to find the area, okay, it is 1/2 times the base times the height, okay? 1/2 the base times the height. And for a circle, okay, the circumference, if you're given the diameter, okay, if you're given the diameter, it is the diameter times pi. Now, if you're given the radius, remember, the radius is half of the length of the diameter. So if you're given the radius, it is 2 pi r, okay? So 2 times the radius, pi. And then the area is pi r squared, okay? R being the radius. Now let's go ahead and let's look at some of these examples. So in part 1, the botany club members are designing a rectangular garden for the courtyard of your school. They plan to place edging on the outside of the path. How much edging material will they need? Okay. So here we're given the dimensions of our garden. All right. And it is 16 by 22. And then there's a 4-foot boundary along the edge. Okay. So we got to figure out what the two, well, there's multiple bases and there are multiple heights. Okay. And we got to figure out which is which. Now, the original base of the garden is 16 feet, okay, 16 feet. Now, the boundary along the garden is 4 feet all the way around. So we have a 4 feet base here and a 4 feet base here. So we have to add 16 plus 4 plus 4, and our entire base, the whole base, is 24. And then we have to do the same thing with the height, okay? We have a height of 4 feet. The garden's height is 22, and then the other boundary, which is 4. So 4 plus 22 plus 4, which is 30. Now, if you look right here for the perimeter of a rectangle, it is 2 times the base plus 2 times the height, which is 2 times 24 plus 2 times 30, and we get 108 feet. All right, 108 feet. Feet is our units, okay? In part 2, we're finding the circumference of these circles, all right? Now, in circle M, we are giving the diameter. So we have to use the formula, the circumference is equal to the diameter times pi, or pi times the diameter, whichever one, okay? And so the diameter is 15, and pi is the same. Now, you can leave your answer as 14 pi, or you can go ahead and multiply 15 times pi, and you'll get approximately 47.1, all right? And then our units are in inches. Our units are in inches. Now, for circle T, we have the radius. So we were going to do the circumference times 2 pi r, all right? Now, 2 times the radius, which is 4, times pi, which is 8 pi centimeters, or you could go ahead and multiply 8 times pi, and you'll get approximately 25.1 centimeters. All right, in part 3, okay, part 3 is a multi-step problem, all right? So we want to find the perimeter of EFG, okay? So we have to find the distance between E and F using our absolute value signs, or using the absolute value sign for our Y values, because that is our height. And then we have to find the distance between F and G using absolute value signs because of our X, using our X values, because that is our base. And then we have to use the distance formula for E and G. So distance formula. And then we'll be able to add the sides together to get the perimeter, all right? So first thing I'm going to do is I'm going to find the distance between E and F. Now remember, E and F is our Y values, so it is equal to the absolute value of 6 minus negative 2. All right, 6 minus negative 2 is 8. Absolute value of 8 is just 8. And then we have FG, okay? And FG is, F is 3, and G is negative 3. Okay, looking at the X values, because this is our base. So 3 minus negative 3 is 6. Absolute value of 6 is just 6, okay? Now, for E and G, okay, we have to use the distance formula. So we'll call E x1 and y1. So x1, y1, and G G is negative 3, negative 2, and we'll let negative 3 be x2 and negative 2 be y2, okay? Now remember, the distance formula is x2 minus x1 squared plus y2 minus y1 squared all over the square root, all right? So EG, okay, using the distance formula here, is x2, which is negative 3, minus x1, which is 3, squared, plus y2, which is negative 2, minus 6. All right. So negative 3 minus 3 is 6. 6 squared is 36. And then negative 2 minus 6 is 8. 8 squared is 64. 36 plus 64 is the square root of 100. And the square root of 100 is 10. All right. So EF is 8. So our height is 8. And our base is 6. And then our hypotenuse here is 10. So we have to add these three values together. So 8 plus 6 plus 10. And we get 24. So our perimeter is 24. So in part 4, we are designing a poster that would be 3 yards wide and 8 feet high. How much paper do you need to make the poster? So I'm just going to draw us a little picture. All right, so it's 3 feet wide, or 3 yards wide, and 8 feet high, okay? Well, here our units are different, okay? So I'm going to convert 3 yards into feet. So let's go ahead and do that. So 3 yards is equal to 1 yard over, well, how many feet are in a yard? 3, right? So our yards now cancel. So 3 times 3 is 9. Okay, and feet is left. So we have 3 yards is equal to 9 feet. And then to find the area, 8 times 9 is 72 feet squared. All right. In part 5, we are finding the area of the circle K. And remember, the area of a circle is equal to pi r squared. Now remember, the radius is the diameter divided by 2, where our diameter is 16. So we're going to divide that by 2, and we get 8. And now the area is 8 squared pi, which is 64 pi, or you could go ahead and multiply 64 times pi, and we get 201.06, okay? And our units are meters squared because we're multiplying the radius twice, okay? Now in part 6, okay, in order to find the area of this figure, I'm going to answer the second part first. So it asks, what is another way to separate the figure in part 6? Well, we have to separate it into a triangle and a rectangle. So triangle and rectangle. So I'm just going to cut this top half right here. Now, if the height's 4, then this side right here is 4, and that makes this base right here 8, because 12 minus 4 is 8. So in order to find the area of our triangle, we have 1/2 the base times the height, okay? Now, our base is 8, and our height is 4. So 8 times 4 is 32, divided by 2 is 16, so we have 16 feet squared. And then the area of the rectangle is just base times height, which is 12 times 4, which is 48 feet squared. And to find the area of the entire figure, we just have to add these two together. And 48 plus 16 is 64 feet squared.